Hey Eli, how are you?
Good. How are you?
Good. Do you have a particular page in this packet you'd like to start, or you just want me to go through them all? Or you can even tell me the equation if you want. Hey,
Can you
Danny.
just start at the second page on the graphing part?
Start at the second page on the graphing part. Yes. Let's see. So you're talking about this one right here. Is that correct?
Yes, ma'am.
Okay. Annie, if you have a particular question, just let me know too. Okay, well, first of all, when graphing, and I was thinking and praying about this for you this morning, Eli. I was thinking that, I have told the students, and I don't know if you heard this or not, that for Friday for the test, if you want a note card that kind of gives you some prompts about how to start each various problem, that's fine with me. So if you wanted to do for graphing, if you wanted to like write down, has to be in slope intercept form, and then say, y equals mx plus b, and then you graph the b, which is the y-intercept, and then you use the rest of it to find the you use the slope to find the other points. So that might be a little note that you could make on that note card about graphing, because I feel like what I've heard consistently from all of the students is that they know how to do each of them if they could just get it started. So I was like, maybe a note card would just help everybody know how to get it started. So, you could say it however it would make the most sense to you to get it started. So, in slope intercept form, and the first equation is in slope intercept form. So you want to plot the y-intercept first, and it's a positive 2. So I'll go up 2 from the origin. And then the slope is 3, which is really a ratio. So that's 3 over 1, and it's positive. So I'm either going to go in 2 positive directions or 2 negative directions. So if I go up 3, 1, 2, 3, I would have to go right 1, because right is positive. And then if I go down 3, 1, 2, 3, I would go left 1, because left is positive. Left is negative. So down is negative, left is negative. 1, 2, 3, left 1. 1, 2, 3, left 1. So there's my first line. Okay. And then the second one you need to put in slope intercept form. Yes, if you put cocoa powder in them, you have to. Y equals negative 2x minus 8. All right. So now we're going to plot this negative 8, which I don't think it quite goes there, but 1, 2, 3, 4, 5, 6, 7, 8. And it really doesn't. That's way down here. My slope is negative 2. So that's either going to be negative 2 over 1, or it's going to be positive 2 over negative 1. So that means I'm going to travel in one negative direction and one positive direction. So if I go up 2, 1, 2, I would go left 1. If I go up 2, which is positive, left 1. Well, yay, this is exactly what I wanted to happen. I wanted to be able to put one dot over another dot that I'd already graphed, because that tells me exactly where they're going to intersect. 1, 2 over 1. But I'm just going to keep going a little bit more just so I can be able to draw the line effectively. But where they intersect is the solution to the equation. So this line, or this spot, dot spot, those coordinates are the solution to this system of equations. So let's figure out exactly where it is. I would go over 2 to the left, so that's negative 2, because this side of the x-axis is negative. So, and then I went down 1, 2, 3, 4. So the place where these two intersect is negative 2, 4. Do you want me to do the substitution on this one?
No, ma'am. I got the substitution right.
Okay. Did you get negative 2, negative 4?
Yes, ma'am.
Oh, praise the Lord. That means I got it right then too, because that's the whole point of this exercise, is that if you are doing all three of them correctly, you should get the same answer for graphing, substitution, and elimination. So that's why I like this assignment, because it gives you an opportunity to practice all three methods, and it also gives you an opportunity to ensure that you're correct. And that's why I put it in as a quiz grade. It's a lot of work, and I understand that, but it's great review. All right. The next page. Is Annie still with us? Oh, lots of people with us. Hey, everybody. Okay, and Annie said she needs help with number 7. Do you want me to graph it, or do you want me to do all three? You can type if you want. Okay, cool. All right, I'm going to skip to that one, and then I'll go back to graphing on page 3. Annie, is this the one you're talking about for sure? Just to ensure that we have both the same page 7. Is that it? Yes.
After you do that one, can you go back to the one that you were just on?
The one I just graphed?
Oh, did you graph it? I had to leave.
Yeah, I did.
Okay.
Do you mind, when I post it, do you mind going back and watching the recorded part?
Yes, ma'am.
Okay, thank you. Yes, I can do. Okay, thanks for letting me know, Annie. And Aiden, yes, I can absolutely go back and do elimination for the one I just graphed. And then it's y equals x and y equals 2y plus 2. Let me see if I can find that. This one? Let me make sure this is right. Yeah, okay. So I'll do this one. All right, so y equals x and x equals 2y plus 2. All right, so need to be in slope-intercept form, which is y equals mx plus b to graph. And we're close because we have the y here, and we have the x, and the m is the coefficient on the x. And whenever there's no coefficient, that's an understood 1. So I'm really, really close. But I don't have, quote unquote, anything written for this part. Well, when there's nothing written for that part, we understand that to be 0. So that means this line is going to go through the origin, okay? Because the y-intercept really is here, which is also the x-intercept. And then my slope is 1. So I would go up 1, right 1, up 1, right 1, because we're traveling in 2 positive directions by going up and right, up and right, up and right. That's positive. Both of those directions are positive. And then if we go down and left, both of those are negative. And it takes two negatives to make a positive. So whenever you have a positive slope, you want to travel in either two positive directions or two negative directions. And then when you're done, your line should rise from the left to the right. So that's another way that you can double check and make sure that your slope is correct. Now this one, I'm going to have to subtract 2y from both sides. And now I have x minus 2y equals 2. And now I've got to subtract x from both sides. And I have negative 2y equals negative x plus 2. And now I'm going to divide both sides by negative 2. Lots of steps on this one. Divide everything. So that gives me y equals, this is really a negative 1. So that's going to be negative 1 divided by negative 2. So that's 1/2 x. And now I have a positive 2 divided by a negative 2. So that's going to be a negative 1. So this is y equals 1/2 x minus 1. So I'm going to plot my y-intercept first. So that's negative 1, and it's going to go right here. And now I'm going to use my slope, positive 1/2, to plot my other point. So I can either travel in two positive directions or two negative directions. So if I go up 1, I'll have to go right 2. Up 1, right 2. Up 1, right 2. Up 1, and I've run out of space over here. So if I go down 1, I got to go left 2. Good news. I hit one of my other spots or dots. So this is going to be where the solution is. So down 1, left 2. Down 1, left 2. But I know exactly where the two lines intersect. And that's a lot of times what you want to do. You want to graph until you know for sure you've hit the same spot twice. And once you do that, that's the solution to the system of equations. So figuring out where it was, I went left 2, seems to be a theme, and I went down 2. That changed a little. So my solution is negative 2, negative 2. Now what we want to do is for substitution, we've got y equals x. So, and then we've got x equals 2y plus 2. So we really can do almost anything here. We could actually substitute 2y plus 2 in for this x. Or we could substitute x in where the y is. So either way. So let's see. I will y equals 2y plus 2. I feel like I did something wrong already. Oh, I didn't. Praise God. Divide that by negative 1. And then y equals negative 2. And now, if I plug in negative 2 in for y, negative 2 equals x. So elimination. Y equals x. and x equals 2y plus 2. All right, so we want to get them where everything's lined up. So what I would do is bring my 2y over. There's a number of things you can do on this one because it's so different, but I'm just going to try to keep it in standard form since that's what I typically ask you guys to do. So now I have that, it's in standard form. So we have x minus y equals 0. And now what I'm going to do is subtract both. So I have negative 2y minus a minus y. So that's negative 2 plus y. So that gives me y, negative for y, equals 2. Divide both sides by negative 1. And I get y equals negative 2. And then you kind of go back into substitution. And so you get the same thing, negative 2, and then up here I got negative 2, negative 2. That one was a tricky one. Good one to ask questions about. Did everybody get that one written down? It does say page 7 at the bottom, but it's technically the 5th page of the packet. It says page 7 at the bottom, but it's the 5th page of the packet. Everybody get that written before I move.
Yes, ma'am. Yes, ma'am.
Okay. All right. I'm going to move back up because one of the other questions, that definitely was a tricky one. So great questions this morning, guys. All right. So I'm going to go back to the other one because I was asked about elimination for this one. So y equals 3x plus 2. And 2x plus y equals negative 8, as I think it was what it was. Yeah. All right, so they both need to be in standard form. So this one, in order to get it in standard form, you would have to subtract 3x from both sides. So I have negative 3x plus y equals 2. So now I have negative 3x plus y equals 2. All right. And then 2x plus y equals negative 8. Negative 3x plus y equals 2. So what I'm looking for is the variable with the coefficients that are alike, and that's going to be y. They both have a 1 as a coefficient. Then I check the sign that's preceding it. Both are positive, so that means I'm going to subtract each of the equations from each other, each variable. So 2x minus a minus 3x, that changes that to a plus, so that's 5x. And then these eliminate, which is exactly what we wanted. And then negative 8 minus 2, that's going to be a negative 10. I'm going to divide both sides by 5. And that gives me x equals negative 2. I substitute in negative 2 back into the equation. And y equals negative 4. So negative 2, negative 4 for elimination. Okay. All right. If there are no other questions, I'm going to keep going with graphing to the next page. Okay. Any other questions on that one? Anybody need me to do substitution on that one? Okay. Then I'm going to keep going with page 3 and start with graphing again. Once again, the first thing with graphing, if you all are making note cards for the test on Friday, I would definitely suggest to make yourself a note that in order to graph, the simplest and quickest way is to put it in slope-intercept form. Slope-intercept form is y equals mx plus b. This second equation is already in slope-intercept form. That first equation, in order to get it in slope-intercept form, I need to subtract the x from both sides in order to get that y all by itself on the left-hand side of the equal sign. So now I have y equals negative x plus 2. Definitely want my x to lead the way so I can figure out what my slope is. Okay, so here I'm going to graph my y-intercept first, and it's a 2. So I'm going to go up 2. That's my y-intercept. And now I'm going to use my slope, which in this case is a negative 1. So remember, the slope is a ratio, rise over run. So with a negative, you're going to travel in one direction negative and one direction positive. So I'm either going to go down 1 in this case and right 1, or I'm going to go up 1 and then left 1. So if I go up 1, left 1, up 1, left 1, up 1, left 1, because up is positive, left is negative. Up is positive, left is negative. So if I go down 1, I would go right 1, because down is negative, right is positive. Down, right, down, right, down, and right. And then what you want to remember after you graph your line, you want to hope that you connect the dots, first of all. And then you want to also ensure that because it's a negative slope, you're going to be falling from left to right instead of rising. You're falling when it's negative, rising when it's positive. So you can see that our line is falling from left to right. So that's just another check to make sure that you've graphed it right, is to check and figure out what the slant on the line is. All right, on that next one, the first place that you go is your y-intercept. So you're going to graph the negative 1 there, and then your slope is a negative 2. Once again, reminding you, slope is a ratio, rise over run, and it's negative. So I'm going to travel in one direction negative, one direction positive. So if I go down 2, I would go right 1. In this case, if I went up 2, I would go left 1. So up 2, right 1. Bingo, I've already hit my spot. I've already connected with this same spot twice. So that's going to be where these two lines intersect. And that's what we're looking for. So you really want to graph these lines to the point that you're actually hitting the same spot twice, because obviously if you're hitting the same spot twice, the lines are intersecting. So now let's take a look and see where it intersects. What are the coordinates? Guess. Baby, I'm not talking to you. So you would go right, if I went right 1, so that my coordinates are 1, 1. Okay. All right. Are there any
Miss Sparks.
questions about? Yes.
For substitution and elimination, I got -3 and 5.
Okay. Well, let me double check. I thank you for letting me know. What did anybody else get? Huh?
I got the same thing as Eli.
Ooh, well, maybe I graphed it wrong. Let me see. Y equals. Is that what everybody else got for this one? Anybody see how I graphed it wrong? Well, it should be -3, 5. So I obviously graphed something wrong. Okay, so let's see where 3, 5 is. 1, 2, 3. Oh, you know what? I did. I graphed this one with a positive slope because my, because my graph is rising to the right. Remember that double, you know what? I wanted those dots to connect so badly. So there you go. Thank you, guys. Let's take a look. We know this part is right. Yep. If I went up 2, I had to go left 1. Up 2, left 1. So it's a good thing y'all caught that. Up 2, left 1. There they connect. Good job. Way to go, guys. 1, 2, 3, or yeah. 1, 2, right 1. Good job. So this one falls, right? Now y'all all have to erase. Okay, so 1, 2. There's 3, and there's 5. So -3, 5. Good job. So y'all got oh, you did okay on substitution and elimination then obviously on this one. Because the answer is -3, 5. And once again, my graph, when I was looking at my graph, the other one was rising from the left to the right. So that tells me that's positive slope. And this has a negative slope. And now the graph is falling from left to right. Okay, sorry about that. Any other questions on that one? Does anybody? Oh, thank you, Aiden. You caught it. I don't know how long ago you caught it, but yes, thank you. Oh, okay. All right. And I'm glad you caught your mistake on the other one too. It's always good to be able to see what we're doing wrong. And obviously we all make mistakes. You know, it just happens. But I hate that if I made y'all erase, so I'm really sorry about that. Anyway, all right. Any other questions? Any other questions on this one? Substitution or elimination for this one?
Miss Sparks, can you do page 4, substitution and graphing?
Page 4? Yeah, I sure can. Is that this one?
Yes, ma'am.
Just to confirm. Okay. I just want to, yes, I absolutely can. Okay, so we have to be in slope intercept form. So 3x minus 6y equals 12. Going to subtract 3x from both sides. -6y equals -3x plus 12. Divide everything actually by -6. So that's going to give me y. I'm going to do it up here. The -3x divided by 6 is a positive 1/2 x. And 12 divided by a negative 6 is negative 2. So the first line is y equals 1/2 x minus 2. Hey, did anybody get any snow anywhere?
Nope.
I did.
Yeah, I did. You did? Who said that?
No, I said I didn't.
Oh, you did not. Yeah, I didn't either. All right. Eli, you're probably the furthest north. Did you get any?
I got some flurries.
You got more than the rest of us. 4y equals negative 2x plus 8. Divide both by negative 4. And now I get y equals negative 2 divided by negative 4 is a positive 1/2 x. And 8 divided by negative 4 is negative 2. Well, look, those are the exact same line. Y equals 1/2 x minus 2. So the good news for the graphing part is you only have to graph one line. So we're going to find, and you just got to hope you graph this one right? You got to plot the y-intercept first. So that's negative 2. Y'all watch me. And then the slope is 1/2. So I'm going to travel in 2 positive directions or 2 negative directions because the slope is a ratio, rise over run. So if I go up 1, I'll go right 2. That's 2 positive, right? Up 1, right 2. Up 1, right 2. Down 1, left 2. That's 2 negative. Down 1, left 2. And now for substitution, I'm going to go ahead and use one of my lines that's in already in slope intercept because I've already done that here, and that's really okay. And then I'm going to substitute it in to the other one. So I'm going to take 2x minus 4 times 1/2 x minus 2. I can't imagine why y'all wanted me to do this. Fractions, y'all love fractions. 2x, and then negative 4 times 1/2 x is negative 2x, and negative 4 times negative 2 is a positive 8. And these two eliminate, and 8 equals 8. So it's infinite solutions or same line. And then substitution or elimination is 3x minus 6y equals 12. And then 2x minus 4y equals 8. So I want my line, I'm looking for the one that has the same coefficient, and neither of them do. So I would have to multiply both of them. This one by 2 and this one by 3. So 2 times 3x is 6x. 2 times negative 6y is negative 12y equals 12. And 3 times 2x is 6x. And 3 times negative 4y is a negative 12y. And 3, I did that wrong. 2 times 12 is 24. And 3 times 8 is 24. I knew I did something wrong. So now we're going to subtract both, and you can see that they all eliminate. and you get 0 equals 0. So that's an infinite number of solutions because that's a true statement. So same line. Everybody get those? And I did the graphing on this one. I'm going to move on to the graphing on this one. This is page 6 of the packet, and it's labeled page 9. Once again, you want to put them in slope-intercept form. So this one's already in slope-intercept form. This one you have to get in slope-intercept form. Subtract 2x from both sides. And you get y equals negative 2x. So on this one, you're going to plot the y-intercept first, which is a negative 4. So I'm going to go down 4 from the origin. 1, 2, 3, 4. And then I'm going to use the slope, which is 2. Once again, reminding you it's a ratio, rise over run. It's positive, so I'm going to travel in 2 positive directions or 2 negative directions. So if I go up 2, I'll go right 1. Up 2, right 1. Up 2, right 1. And to double check myself, I did say it's positive. So my line should be rising from the left to the right. All right. So this next one, y equals negative 2x. Remember, if there's nothing there for the y-intercept, it's an understood 0. So the origin is your y-intercept. So my slope is negative 2. So it's going to be, I'm going to travel in 1 positive direction and 1 negative direction. So if I go up 2, I'll go left 1. But if I go down 2, I'm going to go right 1. And there I go. At least I hit one of my dots. That's the whole goal. You want to hit one of your dots twice because that's going to tell me exactly where they intersect. Okay. And just to make sure, I did say my slope was negative. So my line should be falling from left to right, right? So, and this is where they intersect. And let's take a look. And they intersect. I went over 1. And down 2. So 1, negative 2. Have y'all already done this one for substitution and elimination? And did we all get the same thing? Does anybody want me to do the substitution and elimination?
Can you do both of them, substitution and elimination?
I absolutely can. Did you say something, Mary Faith?
Yeah, I just asked if you could do substitution.
Yes, I can do that. Okay, substitution. One of them is already has an isolated variable. Remember with substitution, you want to isolate like a variable on one side so you can get an expression. Okay, doesn't matter whether it's X or Y, you just want to make sure that there's one variable on the left and the rest of the equation is on the right. Okay, because then what I'm going to do is take this equation, okay, and I'm going to take this piece of it, since y equals that, Wherever there's a y in the second equation, I'm going to substitute it in for the variable. So I substituted, this is the other equation, and I substituted this in for it. So 2x plus 2x is 4x. Add 4 to both sides. So I have 4x equals 4. Divide both sides by 4. And x equals 1. And now what I'll do is I'll substitute that 1 in for the x. So y equals 2 times 1 minus 4. Y equals 2 minus 4. Y equals negative 2. So the answer is 1, negative 2. Okay? 2x plus y equals 0. Y equals 2x minus 4. Okay. So what you want to do is get them both in standard form. So I'm going to subtract 2x from both sides. 2x plus y equals negative 4. And then I have 2x plus y equals 0 because you got to line them up. And now you can kind of pick here which one you want to use because we have the x's that match and we have the y's that match. If you picked the x's, they both have a coefficient of 2, but they have different signs. So if you have different signs, you would add the two equations. If you pick the y, which have matching coefficients of 1, they both have plus signs. So you would subtract. Which one do you want me to pick? Because either one is okay. You just have to know which operation to use. Does that make sense? Opposite signs you add, same signs you subtract. So if I pick the x's, I've got to add the two equations. If I pick the y's, I've got to subtract one equation from the other. Anybody have a preference?
Eli just asked if you could do that again.
Yes. If you, the x's, and Aiden said that he would subtract. So that means he would pick the y's, which is fine. If you pick the x's, this x has a negative on it. This one has a positive. So you would have to add the two equations together if you were trying to eliminate the x's. If you're doing the y's, which is what Aiden said he would pick, they have a matching coefficient of 1 with the same signs. So he says that he would pick the y's and subtract the equations. So that would eliminate the y's. Now I have a negative 2x minus 2x, which gives me a negative 4x. Negative 4 minus 0 is a negative 4. Divide both sides by negative 4. And x equals 1. Then I'll substitute that 1 back into either one of the equations. It doesn't make any difference. Y equals 2 times 1 minus 4. 2 minus 4, and then negative 2. So y equals negative 2. So the solution is 1, negative 2. Everybody get that? I'm going to move on to the next page, which is page 7 in the packet, but labeled number 11. Labeled page number 11, but it's actually the 7th page in the packet. All right, so yay, both of these are in slope-intercept form, so we can just begin. That first one doesn't have a y-intercept written, but we know that and understand that to be 0. So the origin is the y-intercept. We also have a slope of -1. So that means I'm going to travel in one direction negative and one direction positive. And it's a rise over run. So if I go up 1, I've got to go left 1. Up 1, left 1. Because up is positive, left is negative. If I go down, I have to go right because down is negative, right is positive. And once again, as I'm drawing my lines, I want to think about I have a negative slope. So that means that my line, after it's drawn, needs to fall from the left to the right. Fall from left to right. If the slope is negative, it needs to fall. All right. On this one, unfortunately, the y-intercept is 12, and I think our graph only goes to about 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it would be like way up here. So what I'm going to do is actually substitute a -2 to kind of get me started in for the x. So that's going to give me y equals -6 plus 12. So y equals 6. So I'm going to go ahead and plot a point there to get me started. And that is another way to do this, because remember, whatever you substitute in for an x, that's your independent variable. What that y is at that outcome is that will be an ordered pair on that line. 1, 2. So I go left 2, and then 1, 2, 3, 4, 5, 6. So I can start there and then use my slope, which is 3. And I have to travel in one positive direction or in 2 positive directions or 2 negative. So if I go down 3, 1, 2, 3, and left 1, I've already hit the spot. Yay. And then down 1, 2, 3, left 1, down 1, 2, 1, 2, 3, left 1. So that was kind of unique. This was definitely a unique situation on this one. But remember, an ordered pair is a solution to the equation on the line. And what we're looking for is the ordered pair for the solution for the system of equations, which would be a solution to either one. So that's why they intersect there. So I would go 1, 2, 3, left 3, or -3, and then up 3. So that should be the solution to this system of equations. Does everybody understand what I had to do because I couldn't graph the...
I'm not entirely sure where you got the second line.
The second line? Okay. And I clicked back over here, and yes, I will do page 21. And Kennedy, I think you said page 13, and I'm not sure. I think that might be the next page, but I will definitely get to that. Okay. 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 So track with me here for just a second. Normally, we plot our y-intercept first. Does everybody understand that part? That's normally what we do, correct?
Yes. Yes.
Okay. All right. So because that was off the graph here, what I want to do is pick a point on the line that I know is going to be on my graph. My x is always my independent variable. So I can plug whatever I want to into x and then solve for y. So obviously I want this to be smaller than 12 because my graph really only goes to about 8. So I need it to be smaller than 12. And in order to make it smaller, I chose the number -2 to plug into this equation. I could pick any number I want to. I could pick 4. I could pick anything I wanted to. But if I picked 4, that's going to give me 24. That's even further off the graph. But I can pick any number that I want to because x is the independent variable. And I'm trying to pick something that I know is going to be on this graph. So I picked -2. Does that make sense?
A little bit more, yes. A little bit more, yes.
Okay. Do you understand that ordered pairs, like if I picked this ordered pair right here on this line, let me just highlight this. If I pick this ordered pair on the other line, if I were to plug in, what are the points to this line? Tell me what those coordinates are to the green dot.
-1, 1. -1, 1.
Okay. Well, technically, it's 1, -1 because you state the x first, yes? So what happens if I plug in -1 and 1? They equal, right? So that is a solution to that equation. All these ordered pairs that I've colored here, those are all solutions to that first equation. If I took any of these ordered pairs and plugged it into that equation, it would equal. Does that make sense to you? That was like chapter 3.
Yeah, that makes sense. Yeah, that makes sense.
Okay, so because I was looking for a ordered pair that would fit on this line, that's why I picked this particular one, because that would be 1, 2, 3, 4, 5, 6. See, it was -2 and 6. So I plugged in -2 and I got, once I plugged in -2, that gives me a -6, right? 3 times -2 is -6, right?
Yes.
And -6
Yes.
plus 12 is 6. So that's how I got that point. Because I couldn't really use that y-intercept, I had to find a different point to start with and then launch from there using my slope. Does that help? Or does it clear up at all?
Yes, ma'am. Yes, ma'am.
Okay, cool.
Thank you. Thank you.
Yeah, there won't be anything like that on the test. You won't have to do that. You'll be able to plot all of the y-intercepts, but it's a good idea to be able to understand that all of these ordered pairs are actually solutions to these equations. You're just looking for the solution that matches both equations. And that would be where the two lines intersect, because this dot right here is on both of the lines. So that ordered pair is a solution to both of them. We could actually take -3 and plug it in to this equation. So like if I took 3 and I plugged it in to that first equation, that's a solution to that one. If I took this one and I plugged in 3 equals 3 times -3 plus 12, 3 equals -9 plus 12, 3 equals 3. That is a solution to the first equation, and it's a solution to the second equation. So you know that that is a true statement. That's how you check it. I haven't required you to do that, but perhaps I should have, just to make you guys understand that all of these ordered pairs can actually be plugged into the equation, and it should come out to be a true statement every time. Every ordered pair on a line should work those points back in. All right, let's work on the substitution for this one. Y equals -x. So what I'm going to do is plug that. Let's see. Actually, what we can, and then y, I could set these equal to each other. Because if y equals one thing, y equals -x and y equals 3x plus 12. I actually can set those equal to each other. So -x equals 3x plus 12. So I'm going to subtract 3x from both sides. So that's -4x equals 12. Divide both sides by -4. And x equals -3. Now I'll take -3 and plug it back in and so the solution is -3, 3. So on elimination, on this one, most of the time I tell you guys on elimination to make sure that they're in standard form. But on this particular one, you could leave it like this if you wanted to and eliminate the y's. But is that going to confuse you guys? Would you rather me just continue to do it in ax plus by format? What do you guys want me to do? Just always keep it the same? No one cares? Oh, somebody was about to answer me. Keep it the same. All right. Got you. Thank you for speaking up. Okay. So what I'm going to do then is I'm going to take each one and put it in standard form first. So I'm going to add x to both sides. So x plus y equals 0. And then the other one is y equals 3x plus 12. So what I'll do on this one is subtract 3x from both sides. And I get -3x plus y equals 12. So now I'm going to line up my equations. And I notice that my y's have matching coefficients of 1. I check the sign that precedes the coefficient. They're both addition. So I'm going to subtract this bottom equation from the top. I have x minus a -3. So that gives me a positive 4x. The y's eliminate just like we wanted them to. And then 0 minus 12 is negative 12. Divide both sides by 4.
Can you scroll down a little bit?
Yes. Thank you for asking.
Thank you.
X equals negative 3. And now I'll plug in or substitute, because once you do that first step of elimination, you then move back to good old substitution. And my ordered pair is negative 3, 3. Oh, praise the Lord. I get it now. Yay. Praise the Lord. Praise the Lord. All right. I had somebody that wanted page 13 and somebody that I'm going to move up. Is everybody ready? Page 13, which is this page. It's number 8 in the packet. And then I had somebody that wanted 21. So page 8 and 9 in the packet. And I'm gonna those are the next 2 that I'm gonna do. So if you're one of those, hang in there. All right. So for graphing, once again, if y'all are making note cards for the test on Friday, I just remind you, make a note to yourself that says the easiest way to graph is slope-intercept form. And that's going to be y equals mx plus b. Just to remind you once again, just make that note to yourself. These are in slope-intercept form, but once again, they are missing that y-intercept. You don't have to write plus 0 because plus 0 doesn't really add anything to an equation. So if you see something and it's not, you have an equation and it looks like this, but doesn't have that plus 0 there, please remember, if you need to add it, just to remind yourself that that's the y-intercept is the origin. That's the big deal on that, okay? It's the origin. The slope is still the same. It's still the coefficient on the x, which on the first equation, the slope is 4. And the second equation, the slope is negative 3. Remembering that the slope is a ratio, so it's really 4 over 1 or negative 3 over 1. And when the slope is positive, we travel in 2 positive directions or 2 negative directions. So if I go up 1, 2, 3, 4, I'll go right 1. If I go down 4, 1, 2, 3, 4, which is a negative direction, I'll go left 1.
Miss Sparks, why do you start on 0?
Because remember, we always start with that slope on the y-intercept, right? You start with the y-intercept, and the y-intercept in this case is 0, remember? Because if there's nothing written there, the y-intercept is 0.
Oh, right, you assume it's 0. Okay.
Yeah, so this one, what's the y-intercept on the second one?
0.
Right, so I'm going to start at the exact same space, right? Good question.
Yes.
Keep clarifying those questions. All right, so on that next one, like Mary Faith just said, we're going to, the 0, it's understood, that's the y-intercept, so we start there, and lo and behold, we've made a dot twice. So that means we've already found our intersecting point, and it's the origin. Okay? But just to make sure that we know how to graph, it gives us another exercise in graphing. We've got a negative slope. So that means this time my line's going to fall from left to right. My other one was a positive slope, so it rose from left to right. This one, if I go up 3, 1, 2, 3, that's traveling in a positive direction. I need to go left because that's negative. If I go up 3, that's positive. I'll go left 1 because that's negative. If I go down 3, I would go right 1 because that's positive. Down is negative. Right is positive. Didn't mean to make a dot there. Okay, so that's that second line. And they intersect at the origin. 0, 0 is the solution. Okay, for substitution, you have y equals 4x and you have y equals negative 3x. So for substitution, I can set them equal to each other. Because if y equals 4x and y equals negative 3x, then it stands to reason that 4x would equal negative 3x. I'm going to add 3x to both sides. Do not panic when you see this. You can get 7x equals 0. Divide both sides by 7. I'm not dividing by 0. I'm dividing by 7. And that equals x equals 0. I'll substitute 0 back in to one of the two equations. Y equals 4 times 0. Y equals 0. So 0 equals 0, or 0, 0 is the solution. Y equals 4x. Y equals negative 3x. I'm going to get each of these. Oops, I'm not going to write it that way. Sorry about that. I'm going to have more room if I write it differently. Once again, keeping it the same. I'm going to subtract 4x from both sides. And I get negative 4x plus y equals 0. And over here, I have y equals negative 3x. I'm going to add 3x to both sides. (3x plus y equals 0). And now I'm going to line them up because they're both in ax plus by format. My y's have matching coefficients. So I check out the sign preceding the y's. They're both addition. So matching signs means I'm going to subtract one equation from the other. So I have negative 4x minus 3x. So that's negative 7x. The y's eliminate. And now I'm going to divide both sides by negative 7. And x equals 0. Substitute the 0 back into one of the two equations. And I get 0, 0 all 3 times. So I know that I'm correct. Yes, baby. Sorry about that. Does that help?
Yes. Yes.
Okay. Did everybody get those? All right. I'm going to move on to the next page. It's page 9 in the packet, and it's labeled page 21. All right. Once again, for graphing, it needs to be in slope-intercept form, which is y equals mx plus b. If you look at the equation and you don't immediately see a b, if you will, you kind of know that it's plus 0. So 0 is going to be your y-intercept. So I'll plot that first. And the slope here is 1 because the understood coefficient, if there isn't one, is 1. It's also positive, so that means I'm going to travel in one positive direction and two positive directions or two negative directions. Sorry about that. So if I go up 1, I'll go right 1. Up 1, right 1. And you can already see that my line is rising from the left to the right. Just another indication and confirmation that I'm actually plotting my line correctly from a slope standpoint, because a line with a positive slope rises from the left to the right. So on this next one, you know that the y-intercept is a positive 2. So we'll go up 2 and plot that first. And now I see that my slope is a negative 1. So that means I'm going to travel in one negative direction and one positive direction. So if I go up 1, that's positive. I would go left 1, up 1, left 1, up 1, left 1. But if I go down, I would go right 1. And there I've got it. I hit the same point twice. So I know that that's going to be the solution to this system of equations. Because if I color a dot over another dot, I know that I've got it right. Because that's what I'm looking for, is 2 points that match. All right. And that point is 1, 1. I also want to point out something else to you just as a reminder. 1 and negative 1 are reciprocals. They're actually opposite reciprocals of each other. So these are special lines in that they're also perpendicular, because lines that are parallel have the same slope and lines that are perpendicular have opposite reciprocals of each other. That was chapter 4, I believe, but you will also have that a lot in geometry. Very, very important thing to remember. Parallel lines have the same slope. Lines that are perpendicular have opposite reciprocal slopes. Okay, for substitution, I have y equals x and y equals negative x plus 2. So I can actually set the two equal to each other. Because if y equals x and y also equals this, then I can set them equal to each other. I'm going to add x to both sides. Now I have 2x equals 2. Divide both sides by 2, and x equals 1. And now I'm going to substitute 1 back in to one of the two equations. It really doesn't matter. But if I do that, Finn. Sorry about my dog. So substitute that back in, and I get 1, 1 as the ordered pair. So 2 times I've gotten the same thing. So that's good. Now, y equals x. Okay, my dog's going crazy. I'm sorry, y'all. My dogs have been bad during math lab today. Negative x plus 2. All right. So I'm going to, in order to get it in ax plus b format, I'm going to subtract x from both sides. And don't panic if ever you get a 0 on one side. That's just not really a big deal. And then negative x over here. So that's negative x plus y equals 2. So now they're both in ax plus by format, which is really what you need for elimination. That's ax plus by equals c. That's standard form. And this way you can make sure your x's and your y's line up. And on this one, we can see that our x's and our y's both have matching coefficients. And they also have matching signs. They're on, if you got the x's, they're both negative. And on the y's, they're both positive.
Miss Spike.
So, yes.
Subtract.
Maybe, did I do something wrong? Yes, I did do something. I needed to add this. I was like, what happened? That's a positive. So they both have matching coefficients, but one is a negative and one is a positive on the x's, and both of the y's are positive. So you would either add or subtract. And I think the thing that y'all are most used to is subtracting. So I don't know, Mary Faith, if you were catching me on that, but good job. So I've got negative x minus x. So that's going to be a negative 2x, and y minus y, they eliminate. And this equals 2. Divide both sides by negative 2. Oh, this is a negative 2 because 0 minus 2 is a negative 2. So x equals 1. So y equals, and I'm going to substitute in. So it's 1, 1. Okay. I'm going to click back over. All right. This is the last page in the packet, which is page 23. Is this the one that you all wanted me to do? Because I've got a couple of them up here. Okay. Is this the one that you wanted to, Eli? This one? All right, it needs to be in slope-intercept form, and neither one of them are. So on this one, 4x plus 3y equals negative 3. I got to subtract 4x from both sides. And I get 3y equals negative 4x minus 3. Divide everything by 3, not just both sides, but everything on both sides. So y equals negative 4/3 x minus 1. I'm going to rewrite that. Y up here so it's a little more visible. 4/3 x minus 1. And then down here, I'm going to subtract 2x from both sides. And I get y equals negative 2x minus 1. Okay, so the first thing I'm going to do is plot my y-intercept, which is negative 1. And then I have a slope of negative 4 over 3. Or I can do positive 4 over negative 3. Because when the slope is negative, I'm going to travel in one positive direction and one negative direction. So if I go up, which is positive, 1, 2, 3, 4, I'm going to have to go left 3. If I go up, which is positive, I'll go left 3, which is negative. But if I go down 4, 1, 2, 3, 4, I would go right 3, because that's positive. So down is negative and right is positive. Just to confirm, I have a negative slope, so my line should be falling from the left to the right when it's negative. So, and it is. So at least as far as that being a check, that's right. And this next one, my y-intercept is also -1. So basically, that's probably going to be our point right there. And our slope is, that's probably because now we actually know that that's going to be the point, because that's going to be the point at which both of them, it's true for both of them. But our slope, just so that we can draw the line, our slope is -2. So I'm going to travel in one positive direction and one negative direction. So if I go up 2, I'm going to go left 1. Up 2, left 1. Or I'll go down 2, right 1. Down 2, right 1. And that line looks like that. But our y-intercept was actually our solution to the equation. On substitution, what you want to look for is which one of these two has a coefficient, has a variable with a coefficient of 1, the first one or the second one? Which of the two equations has a term in it with a variable that has a coefficient of 1? What's the coefficient on this term?
4.
Good. What's the coefficient on this term?
3.
What's the coefficient on this term?
2.
What's the coefficient on that term?
1.
So that's the equation that you want to use for substitution, because that would be the simplest. So basically, you're going to get it in slope-intercept form, and we've already done that over here. So y equals -2x minus 1. So I'm going to use this phrase. And the reason why I wouldn't want to use this one is because if I don't have to use fractions, even as much as Miss Sparks likes them, it would be much easier to use this in substitution, right? So I'm going to substitute that -2x minus 1 in for x in the other equation. So 4 times -2x minus 1 plus 3y equals -3. Distribute the 4. That's going to be -8x minus 4 plus, what happened? Oh, Miss Sparks. For the love of Jesus. I substituted in the wrong place. 4x plus 3 times negative 2x minus 1 equals negative 3. 4x minus, if I distribute that 3, that's 3 times negative 2x, which is negative 6x, and 3 times negative 1 is negative 3. And then 4x minus 6x is negative 2x minus 3 equals negative 3. I'm going to add 3 to both sides. It's going to go down into the elimination side. Then I've got negative 2x equals 0. Divide both sides by negative 2. And x equals 0. Then I'll substitute back in 4 times 0 plus 3y equals negative 3. So 3y equals negative 3. Divide, I'm really getting into this other part. Sorry about that, guys. Divide both sides by 3, and y equals negative 1. Not a lot of room. I bet y'all found that a little bit on the sheet anyway. So I did, in fact, get 0, negative 1. Now for elimination. For elimination, they're already in ax plus by equals c format, which is standard format. But neither one have matching coefficients. So that means I'm going to have to multiply one or both of them. And I could either multiply the bottom one by 3 to get my y's to match, or I could multiply the bottom one by 2 to get my x's to match. To keep everything smaller, I'm going to go ahead and multiply the bottom one by 2. So that's going to give me 4x plus 2y equals negative 2. And then I'm going to line up my other equation underneath it. And my x's match, meaning the coefficients are the same. They're both 4. The sign preceding them is both positive, so I'm going to subtract. That eliminates the x's. And 2y minus 3y is negative y. And then negative 2 minus a minus 3. That's going to be negative 2 plus 3 is going to give me 1. Divide both sides by negative 1. And y equals negative 1. I'll substitute negative 1 back into one of the two equations. Add 3 to both sides. So that gives me 4x equals 0. Divide both sides by 4, and x equals 0. So I get 0, negative 1 as the ordered pair for elimination, for graphing, and for substitution. So that completed the packet. And I feel like between two different math labs, because I feel like another math lab I handled like 3 or 4 of the other ones, but maybe I didn't. Maybe in between class, math lab, I think I've done almost all of them. So, are there any questions?
No, ma'am.
No, ma'am.
Okay. Do you all feel like this has been a better review?
Yes.
You feel good?
Yes.
Better about the test
Yes, ma'am.
coming up?
Yes, ma'am.
Okay, good. Just clarify some graphing questions that you all had?
Yes, ma'am.
Yes, ma'am.
Okay, good.
Yes,
All
ma'am.
right. Well, email me if you have any other questions today. All right. And maybe
Thank
we'll get
you.
some snow.
Thank you.
I don't think so, but maybe. I keep hoping.
Thank you.
Thank you.
Y'all have a blessed day. Bye-bye.
You too. Bye.
You too.